Namaste all, hope you all are doing good. So as part of our system design mastery course, today we are going to look at the scaling patterns part 1. So there are many scaling patterns and we have application scaling, we have database scaling. So today we are going to look at the application scaling, and in application scaling we have many scaling design patterns. Okay, so out of the many we are going to see only 3 as of today. So first is vertical scaling, horizontal scaling, stateful versus stateless architectures. With that mentioned, let's jump on to our first scaling pattern, which is vertical scaling. So let's try to understand the problem first, and with that we'll see how vertical scaling, what is vertical scaling, how it is going to help us in terms of scaling. Okay, so let's say we have one server or system or virtual machine. Okay, it's basically a computer, and for our example, let's say it has one CPU, 4 GB of memory and 4 RAMs. Okay, now the capacity and all and various other properties are there for this system, but we'll try to look at these three as of now. Okay, now with this system, let's say we have hosted Flipkart application on this system. We'll call it as a server in our context. Okay, now on this context Flipkart is running. So with that, Flipkart is running on the application, perfect. Now one user is using it, application perfectly working fine. Two users are using it, it is perfectly working fine. Similarly, more users are working, it's perfectly fine. But now as the load is increasing, the capacity is coming to its threshold. The user request, the amount of request that is coming to the server is crossing the load that this system or this server can handle. So with that we can see the red signal indicator. Now we cannot do anything because there is no scaling in place. So what is scaling? Scaling means increase or decrease the capacity as per the requirement. So in our case, we know that the number of requests is increasing, that is load on the servers is increasing. So what to do? So that's where we are trying to see how vertical scaling is going to help us. Now let's say the same system or the same server. Okay, instead of one CPU, now we kept two CPUs. Okay, instead of 4 GB memory, we have updated to 8 GB memory. Instead of 4 RAMs, we have kept 8 RAMs. So you see, in the same server we have just increased the capacity, or we can see increase the capability of one resource that we had. Okay, so with this, now let's see how the application is going to work. Okay, one user is making use the application, it is working. Two users working, 6 users working, which was failing previously. Now even after more users are coming, it is working, but again this is also going to have its own limitation. Okay, so what are we going to do? Are we going to increase more resources further in the same server? We can do that, but there is certain limit. Okay, so increasing the resource or the capacity of the same server is known as vertical scaling. So let's say this is a person. If vertical scaling means the same person's height is increasing. Okay, so increasing the capacity of the same person is called vertical scaling. So that was our first scaling technique. Now with that mentioned, let's jump on to our second scaling technique, which is horizontal scaling. So what is horizontal scale? Let's try to find out what is the problem, and then we'll try to see the solution with horizontal scaling. We have again same server, we had one CPU, 4 GB memory, 4 RAMs, just like how we had in the previous use case. Okay, one user is using, perfect. Two users are using, perfect. 6 users, capacity is gone. Okay, so now with the help of horizontal scaling, we need to provide a solution. So what to do in our case? So now if we see, we are not modifying the system or we are not modifying the server, but instead same kind of servers we are creating more. So previously there was one server, now exactly same we have 5 servers, as we can see. Okay, so here instead of increasing the capacity of the same server, we have just I can say imitate or created the similar kind of instances or similar kind of servers more in terms of numbers. So here the number of resources increased instead of increasing the capacity of the same resource. Okay, so with this again, one user fine, two users fine, 6 users which were making previously, now it is working fine, more users, it is working fine. So what is the limitation here? Now as the load increases, we can increase as number of resources as possible, because we can create any number of servers, any number of instances, but again it is also not possible that you create infinite because everything associated with the cost. So previously in vertical scaling, the same server or same system, we were increasing the capacity of it, but now instead of increasing the capacity of it, we have just imitated like creating 5 more servers. Okay, so here the count of servers is increasing instead of increasing the capacity of it. So because the count is increasing, we call it as horizontal scaling. With that mention, we'll jump on to our final stateless versus serverless architecture. Okay, what is stateful, what is stateless, what is the difference, how scaling is related to these kind of architecture, in which architecture scaling is possible, in which architecture scaling is not possible, all that we'll try to understand here. Okay, and it is very important questions even for our designing, even for the interviews and all such things. Okay, so with that mention, let's see a use case. Let's assume we have 3 users. Okay, and we have a load balancer on a second step. The load balancer will be getting the request from all the users, and let's say after load balancer there are 3 web servers as of now. And let's assume there is an e-commerce application which is being hosted on these 3 web servers, and it has a database. Okay, now there is one more assumption. Let's take for our use case that adding an item to the cart is based on the cache mechanism. Okay, in our context we'll focus on cache, and in detail about cache is a separate video, but it could be cache, it could be cookies, or it could be session. Okay, but for our understanding, let's stick to the term called cache, no cookies as of this context. Okay, but all 3 can be used, and we'll see in detail in a separate video. So we are clear, we have users, we have load balancers, we have web servers on which an e-commerce platform is there, and this e-commerce platform has a database as well. Okay, and this e-commerce platform has a functionality of adding items to the cart using cache. Okay, so let's say user 1 made a request, it came to load balancer. Now load balancer sees the first server, web server 1 is free, so it will redirect to web server 1. Okay, now web server 1, what it will do, since the request came to web server on first time, it will make sure to have the complete request looked into and store the relevant detail in its cache, so that next time when the request comes, the web server 1 can process it quickly without focusing on unnecessary details but on the core details. So when we say unnecessary details, good details, core details, let's take an example. So username password is received to load balancer, it will go to web server 1, web server will check in database. Okay, he is a valid user, let's give back the token and 3 other metadata attributes. Okay, so that will be returned to the user 1. Now next time whenever he is performing any request on the e-commerce platform, they will send a request, and instead of sending the whole request every time, they will simply send one metadata and its functionality, that add this item to the cart, or check out or do the payment. These are the core items of the request. Okay, but to identify that user, let's say one attribute of metadata is being sent. Okay, now let's say user 1 is saying add this item in the cart, request went to load balancer sent it to web server 1 again. So why is it not sending it to web server 2, web server 3 every time? Because load balancer now knows, okay, this request came previously and I redirected it to web server 1. This is called sticky session. Okay, basically load balancer, if redirects the request from a specific user to a specific web server, next time also it will do the same. Okay, so the reason here is fast processing. Okay, now load balancer knows web server 1 already has a cache of this user, so it can do processing quickly, right? So again, there is a limitations for this implementation also, and we have various implementation of this in load balancer itself. But for now, assume load balancer knows that because of this I redirected to web server 1. Web server 1 will process. Okay, web server 1, what it will say, it will see the request and it will say, okay, based on this metadata attribute, I remember who are you and I have all this 10 details about you. Okay, what is it that you want? Okay, you want to do some checkout. Okay, you want to search for this item. It will quickly validate the user, it will do its processing, communicate with database, whatever is needed for the request, and will return the response. Okay, same is happening with user 2. Load balancer says, okay, web server 1 already has one resource busy, I can redirect it to web server 2 so that I can maintain the load across the different servers. Okay, with that mentioned, the web server 2 will also store the cache of this user 2 process and return back. User 3 also sends a request. The load balancer sees, okay, there is one more server which is free, so to maintain the load I'll redirect the request to web server 3. So web server 3 will store the cache, do the processing and returning it back. So far everything is good, perfect, and it's working fine. Okay, now let's say web server 1 crashed. Okay, so web server 1 crashed. Now the user is saying, okay, add one more item to the cart. Okay, so what the user 1 is sending, it's a core request that this item add to the cart along with one metadata attribute for the identification of the user. Now load balancer, if it is implemented using sticky session, then it will, instead of checking whether web server 1 is crashed or it is working fine, web server 1 is healthy or not, it will simply redirect the request of user 1 to web server 1. So what is going to happen here, it's going to fail, right? And let's say sticky session is not there, then what will happen? Load balancer will say, okay, this request previously went to web server 1, but now since web server 1 is not healthy, it is crashed, I should redirect it to some other server. So the request will be redirected to web server 2. Now web server will 2 will say, oh, this metadata attribute I don't recognize. What should I do? I cannot process this request because I don't know this user, and the user did not send full request because the user was thinking that one metadata attribute is sufficient. Now here when we say user thought and all, it's basically called client implementation. Okay, so what will happen in this cases, because web server 2 did not recognize this user, it will be logged out because no session is there, no cookie, no cache, nothing is there. So the request will fail and the user will be kicked out of the application. So user needs to log in again and add all the 10 items which he or she added previously, and then continue the same. So here you understood the issue with the session, cookies, cache, and the bad thing that the user experience had, and all these things. Okay, so this maintaining of cache, cookies, session is called stateful. Okay, so in the stateful architecture, it is excellent for the faster processing, but it is also impacting the scaling. So how it is impacting the scaling, let's look at the issues. First issue is availability issue. Like we have seen, load balancer, if it is implemented using the sticky session, will be sending the request to web server 1 though it is crashed. Okay, only when the load balancer is using sticky session. Second, scalability issues. So there are multiple scalability issues, but we'll look into it after a minute. Okay, third, sticky session blockage to horizontal scaling, uneven server load. Okay, so here we have, okay, so sticky session also we have understood. So how it is blocking to horizontal scaling, just hold on for a minute, we'll learn about it. Okay, heavy resource consumption. So when we say heavy resource consumption, what is it? Heavy resource consumption, let's say we have 300 users, so 100 users will be redirected to web server 1, 100 to web server 2, 100 to web server 3. Now for all the 100 users maintaining session, cookies, cache, a resource of the servers will be utilized. So that is called heavy resource consumption. So what is the alternate of it? Just hold on, we'll look it in a minute. Okay, fifth is load balancing obstacle. Okay, so we have seen sticky session again, and there are multiple more things, but we'll keep it simple for this now. When we specifically talk about load balancer and these caching things, then we'll go in more detail. Sixth is failover complexity. Okay, so when we are going to study about replication, we are going to see about it, but if you already know about it, perfect. But basically in stateful architecture, we have so many scaling issues available. Issues are present. Okay, so let's go to stateless architecture. So what is going to happen here? Again, we are going to have 3 similar users, we are going to have a load balancer, and then we are going to have web servers. Okay, so here also 3 web servers. Previously also we had 3 web servers. Here also we have a database, just like previously how we had a database. So before understanding how the flow is happening, let's see what is the difference so far. So far I see similar users, similar load balancer, and a database. So just the way the servers are present is different. So what is it that is making difference? Here when the load balancer is coming, only thing that will be looked by the load balancer is which resource or which server is taking less, or which server is processing less requests at the moment. So I will redirect the request to that process, that specific web server. It will not have a sticky session, because none of the load balancer will not have a sticky session, web servers will not have a sessions, cache, cookies, nothing. Okay, so every server is equal in front of load balancer at this point of time. So as soon as the request come, load balancer will only see which web server is a bit less loaded or less busy. I will redirect the request to that specific server. Okay, now let's try to understand the flow. User 1 sent a request to load balancer. Load balancer sent to one of the server which is a bit more free compared to others. Now at this moment, when web server is processing the request, it is going to store session, cache, everything in a separate storage, in a storage, common storage for all the web servers. So it's not database but some other common storage which is common for all these web servers. Okay, now this also cookies or cache or session is not stored for every use case but for a few use cases. So in stateless architecture, one thing is for sure, that none of the web servers are going to store any kind of state of any kind of request. Okay, second, if on the overall architecture or overall application, if caching needs to be implemented, it needs to be implemented on application level and not on a web server level. Okay, when we say application level, means the caching will be implemented so that the caching is done at a common storage which is accessible by all the web servers. Okay, shared storage we can say. Okay, so user 1's request is redirected to one of the server. It stored something in the common storage, or we can say did caching in the common storage if relevant. Otherwise that is also not done at all to maintain the stateless. Then if anything communication or anything required as part of the process to, as part of processing the request to communicate to the database, that is done and the response is returned. Similarly, user 2 made the request, load balancer did not have any sticky session or anything. It simply redirected to web server which is having a bit more capability compared to other at that moment. Okay, and then the processing is done and reverted back. Similarly, user 3 request load balancer sent it to server, it did the processing, returned it back. Okay, so this is how the stateless architecture works, where web server will not maintain a cache at all, and if it is maintained, it is maintained at a commonly accessible area. Now, commonly means all the web servers can access that shared storage. So few examples of it as lambda functions, Kubernetes and cloud functions. So that was our last scaling technique for this video. We have many more coming up. So remember, the scaling techniques that we have seen today are few of the application scaling techniques. Okay, we have database scaling techniques and many more application scaling techniques as well. Any queries, any doubts, to mention in the comment section. Any suggestion is very much appreciated. Let's meet as part of the system design mastery in another topic with one more video. Have a good day ahead. Thank you.